Hey guys, this is Miss Smith. Today we are going to go over arithmetic sequences, recursive and explicit forms, and they're not as hard as they seem. So let's jump right in. For recursive sequences, those are the first things we're going to look at. The recursive, I don't know why my screen's not changing, there it goes. The recursive format of sequences, with a sequence being any type of constant going up or down by numbers, a constant number. We're going up, kind of think of your slope. You know how on a linear function that we've just been doing, we're going up by a constant value. It doesn't change unless we're changing the interval entirely. So we were going to look at simply the two types of formulas that we can look at in sequences, recursive and explicit. The first one being recursive. So in recursive, we are given the general rule, if I can get out of that, there we go, an, which, do you see how small my n is? It's small. It is not supposed to be on the line. If you write an, that's wrong. That's an English word that goes before pronouns or something. No, A, E, I, O, U. Any type of vowel words, okay? Again, not an English teacher, math teacher. So we want to make sure we really write that mathematical term correctly. A small n equals a n minus 1 plus d. Okay, again, you see my n minus 1, it's small. D is my common difference. That's what I'm going up or down by. So if we're looking on the right side, okay, if we're looking on the right side, example 1 and example 2, we're going to look at the sequence and we're going to first find what our common difference is. 43 to 49, what are we adding? If you don't know how to find it, use your calculator, do 49 minus 43. You will find that we are adding 6. Now let's check. 49 plus 6, does that give me 55? Yes. 55 plus 6, does that give me 61? Yes. So my common difference for example 1 will always be 6. So what I'm going to do is now all I have to do is, as it says, write the recursive rule. All I'm going to do is literally replace the D in this formula with 6. It doesn't want to write for me. Okay, was that hard? I hope not. That's it. If they ask for the recursive formula, that's all you're doing. You're substituting whatever it's going up or down by for D, and that's how you solve it. So let's look at the one below. The one below, we are now not going up, our sequence is getting smaller. So if it's getting smaller, we are now not adding by a certain number, we are subtracting by 4. So my D here is going to be a negative 4. If I can write it. Apparently I'm struggling with that tonight. Negative 4. Okay? So now all I'm going to do, the same method as before, write it all out. A little n equals a little n minus 1. Instead of adding, you do minus 4. If you do this, a little n minus 1, and then you do plus a negative 4, I'm okay with that too. This is the same. They are equal to each other. That's recursive. The next thing we're going to look at is explicit. Okay? If you got confused about something, just rewind. Explicit is the same type of response. In explicit, we do have to identify what my first term of the sequence is. Once we do that, we can fill in the rest of the pieces. A little n is equal to my first term plus parentheses n minus 1 times my common difference. So you have to find what your common difference is, and you have to find what your first term. So if we're looking at this one right here, what is my first term? It's 43. So A1 is equal to 43, and then my common difference, like we found on the previous slide, is 6. So I'm just going to substitute all my values in. A sub n is equal to 43 plus n minus 1 times 6. Put parentheses around it so that way you know how to put it into the calculator. Put parentheses around things. I promise you it'll save you. Parentheses, parentheses, parentheses. Okay? Now, you can leave your formula like this. That's all you got to do. Example 2, same thing. We knew we're going down. It was a negative 4. So D for example 2 is negative 4. Okay? My first term for example 2 is 74. So we'll do the same exact thing, and we'll plug in our formula. A sub n is equal to 74 plus n minus 1 times, you guessed it, negative 4. Okay? So, if we're using any one of these to find a certain term, let's say with explicit we want to find the 100th term. Okay? I'm going to use this formula on the next slide. Okay, so we're looking for the 100th term using that second formula. It can be any formula for explicit, okay? So finding the 100th term, all we have to do is plug in whatever term they're looking for, which in this case, again, is the 100, and plug it in place of n. So we would write a little 100 is equal to 74 plus 100 minus 1 times a negative 4. What's 100 minus 1? That's 99. And then you would do 99 times negative 4. 99 times negative 4. That's going to get a really large number, which is okay. We can handle large numbers. Sorry, I'm distracting from the fact that my calculator is working. Okay, you should get 74. If it'll write 74 minus 396. What does that equal? I know, sorry. Negative 322. So the 100th term in that sequence is negative 322. That's how you find the 7th term, or 100th term. Okay? If you have any questions, ask your teacher. Quick video. Hope you enjoyed it.